If you're in Calc BC, maybe you'll see this on an FRQ, a rotated region, about an axis of rotation too. Don't use disc or washer, calculate the volume, it's not hard to do at all. So, if they ask for the volume, solid of rotation. If you start to forget the disk method equation, multiply by 2 pi. Integrate radius times the height. A to B, side to side. Shell method is best for dy. So if you're asked to find B, first you need to find the height. If you have two curves, just subtract from the curve with greater y. Don't use disc or washer, calculate the volume, it's not hard to do at all. So, if they ask for the volume, solid of rotation. If you start to forget the disk method equation, multiply by 2 pi. Integrate radius times the height. A to B, side to side. Shell method works best for dy. It's not hard to do at all. So, if they ask for the volume, solid of rotation. If you start to forget the disk method equation, multiply by 2 pi. Integrate radius times the height. A to B, side to side. Shell method is best for dy. Okay, so here's a problem where we're not rotating around the axis. So we're going to rotate around here. This is x equals -4. Our curves are going to be, ooh, that was bad. This is y equals square root of x, and then this is y equals x. Our intercept is going to be 1 and 0. You can figure that out on your own. And then we're going to start by making our shell. And remember, the shell is always parallel to where we're rotating it. And the radius of this part is going to be x, because it can be wherever. And then this is the shell height. So all we're going to do now is plug it into our volume equation, and that's the v equals 2 pi integral of the radius times the height, and then from our bounds 0 to 1, since that's a to b. Our radius isn't just going to be this, since we're rotating it around x equals -4 now. So we're going to add this 4 that we're missing to make the full radius. So it would be x plus 4 as the radius. And then for the height, we're going to do the area between the two curves, like usual. And that's it. Okay, so I rewrote the problem that we did before, but except we're going to rotate around a horizontal axis instead of this vertical one. So the first step is the same. We have to draw a shell, and remember that's always parallel to the axis of rotation. And then this is going to be our height y. our radius, since it's now vertical, and then our height is going to be horizontal. And then all we have to do now is plug it into the volume equation, but we're going to have dy instead of dx. So in order to have dy, we have to solve for x for the equations, and then plug in our values. V equals 2 pi. Our bounds are 0 to 1, 0 to 1 right here. That's our intersection at 1. And then our radius is going to be this y value plus this y value. Since the axis isn't 0, it's y equals -3. And this is 3, so it'd be y plus 3. And then our height. And our height is going to be from right to left, just like when we used to determine the area of the curves. So it would be y minus y squared. So you can also solve this problem probably easier with disk or washer method, because you don't have to convert the equations. That's why it's nice to be able to switch between shell method and the other methods, because depending on like what equations you have.